Patrick Haggerty. Give me one second. Let me pull up a slide here. Maybe. So, okay. So, my name is Patrick Haggerty. I'm a instructor. I mostly do training for Google these days. My background is primarily software development. I've been writing code for a long time. I guess I wrote my first line of code about 1980.
Wow.
I got my first job writing code about 1992. I started in languages like C and Perl. I moved from there to Java. From Java, I moved into C# and JavaScript, and eventually added some Python. These days, the languages I probably most frequently work in are JavaScript, Python, and Java.
Oh, that's amazing, Patrick. I'm really like I have a lot of questions to ask, but I'll
Okay.
just let maybe after the presentations I'll be asking my questions because I want to understand how you could do all of that in over these years, the experience you have gained, and how fast you were to bring all of these programming languages into your tool set. It would be nice to know more about that, but yeah, after the presentation, we can do that.
Okay.
Okay, so the attendees are joining, but the event is already being recorded so that after the event they can have access to the videos if those that couldn't attend will to watch the videos.
Okay.
So yeah, so you can okay, let me also introduce myself. I am Israel, the GDSE lead for Federal University of Technology, Accra. I'm a back-end engineer also. I started about 5 years ago learning. I started with Java, then I moved on to Python because Java was too hard for me. I couldn't understand it then. But Python was much more easier. I regret my decision now, but Python was much more easier. So after I learned Python for some time, now I'm back into static typing. I'm learning Golang and C. So yeah, that's my experience over the years. But yeah, I still have a very lot to learn from you.
Uh,
The community are here to learn about Vertex AI.
yep.
Basically, it's for them to be able to know or understand where they can use Vertex AI in a solution or in any kind of solution they are building, and it's make them have an idea of how it is, and then they can go home and learn more and dig deep by themselves. Okay, so you can go on, Patrick.
Yeah. Sorry about that. The time. Sorry about the time zone mix up this morning, but it happens. Yeah.
No problem. It's my issue.
So last time I was in Nigeria was maybe 5 years ago, and I was there working for Zenith Bank, and they were mostly doing Java code.
Wow.
But anyway, so yeah. Um, so if you think about the idea of machine learning, right? You know, Vertex AI. If I take a look, oh yeah, give me one second. Let me open up. Let me open up one more thing. All right. So if you're talking Vertex AI is kind of in the Google Cloud Console. So, this is your main Google Cloud homepage, if you will, the Google Cloud Console. In the Google Cloud Console, if you go to the main nav menu and scroll pretty much all the way to the bottom, you'll see there's a section down there on AI. Right? The AI section is primarily Vertex driven, right? Vertex AI is sort of Google's central piece for everything machine learning, right? Give me 1 second here. Okay. So Vertex AI is kind of Google's central piece for anything machine learning related. Okay. Now, when you're doing machine learning, in machine learning, you have a lot of challenges. It used to be you pretty much had to be a mathematician if you wanted to do machine learning. These days, that's not really true anymore, primarily thanks to programming APIs like TensorFlow, right? TensorFlow, yeah, I think we're picking up your typing, by the way. You might want to mute yourself.
Oh, sorry about that.
Oh, no worries. Yeah. TensorFlow, if you're not familiar with it, is the most popular of your coding libraries for Python, for machine learning in Python. If you didn't know, some of the top machine learning programming languages are languages like Python. Python is the #1 machine learning language. I don't know why. There's some really nice things about Python. There's some things about Python that I'm not necessarily the biggest fan of, but Python tends to be the most popular language for doing machine learning. You also have a lot of Scala. Scala is kind of in the Java family. You have R. R is used by some big companies for like statistical analyses work, but the biggest programming language for machine learning is Python. In Python, the biggest machine learning API is TensorFlow, right? So if you want to do machine learning work, machine learning is learning by example, right? I take a bunch of data and I try to see if I can teach a machine to learn by example, basically, right? One of the classic examples, if you've never messed with it, is the MNIST example. The MNIST example, basically, if I give you a box and I ask you to write a number in the box, can I teach a computer to recognize what that number is, right? If you've never played with the MNIST example, there's a really good video on it. Give me a second. Yeah. If you want to take like 20 minutes and watch this video sometime, this is a really good video on kind of how machine learning works. How does a neural network, which is one type of machine learning, work? Okay. Obviously, I'm not going to watch it now. Give me a second. Okay, well, let me try that again. But this video does a good job kind of talking about, if you're doing machine learning, if you're learning by example, right, and you're doing something like a deep neural network. Deep neural network is a type of that deep learning in that internal circle, then how can you learn by example? How can you have, say, 10,000 examples of people writing their numbers? And how can you run through the 10,000 examples over and over and over again and eventually figure out how to recognize the number 9? That's kind of deep learning, which is a type of machine learning, right? Okay, now if I'm going to do this kind of stuff in Google Cloud, if I'm going to do this kind of stuff in Google Cloud, Google really gives you, 3 or maybe 4 main ways you do machine learning, right? One way you do machine learning is what I was just talking about, right? You create a custom model using TensorFlow, right? You build a model or you code a model. Well, you code a model in TensorFlow, right? Okay. If you code a model in TensorFlow, then the next thing you need to do is you need to now train it, right? So once you have the model built, you need to go through training. Okay. And to do training, you need compute power, right? Now, the problem with needing compute power is you need a lot of compute power, but you don't really need it for long. You might need to do training for hours, or you might need to do training for days, right? It's tough to say, well, I'd like 10,000 servers to help me train this model, but I only want to use them for 2 hours, right? Without the cloud, that's very difficult to do, right? So this is where, your first piece of Vertex comes in, right? Vertex is kind of the main central area in Google Cloud dedicated to you doing machine learning work, right? Vertex, for example, has features that can allow you to load your data set. Most machine learning requires lots and lots of data. I've got a car that does this thing. When I get too close to the edge of the lane, it bumps me back into the middle of the lane, right? How do you teach a car to recognize where the edges of the lane are, right? Or how do you, your video on your phone does video stabilization, right? How do you do that? I got a text message on my iPhone the other day, and it said, your friend, whoever, sent a picture to you of a child coloring at a table. How did it know it was a child coloring a picture at a table, right? These are things that machine learning does, right? They're in the artificial intelligence world, right? And in order to do something like that, you need lots of data. How do you teach a car to recognize the edges of the lane? Okay. Of course, the last time I was in Lagos, I'm not sure they did much following the edges of the lane. But besides that, how do I teach a car to recognize the edges of the lane? Well, you go out there and you shoot tens of thousands of hours of people driving in different roads and different conditions and different lighting and in different weather. And then you got to load it all somewhere. Okay. How do you teach a credit card service to recognize fraud or not fraud? Well, you look at tons and tons and tons and tons and tons of examples of credit card transactions, and you know whether they were fraud or not. Right. So that's like where your data set would go, right? Your data set is where you upload the data that you're going to train over. Maybe it's 10,000 examples of people writing numbers and pictures, right? Maybe it's, millions of examples of credit card transactions. So that's kind of what you do in here, right? You load up a data set, and then you can create what's called a feature store. Features in machine learning are what you know, right? What you know. When I say what you know, if it's credit card transaction, okay, it's a credit card transaction. I know things like the credit card number, but I also know things like, where am I making this credit card charge, right? What kind of business is this, right? What time of the day is it? Those are features. Those are things right? Okay. The next thing you have to do in machine learning is, like I said, you have to do training, right? Training is where, great, you've coded up a model in, say, TensorFlow. If I wanted to code up, this model in TensorFlow, it's really not much code in TensorFlow. A decade ago, I realized that the concepts of machine learning were invented about 1948. Most of the modern machine learning theory was invented about the time I was born, which is the late 1960s, right? The reason machine learning is so prevalent these days is mainly twofold. One, languages like TensorFlow make the code easy. You don't have to write a bunch of advanced math, right? The advanced math is built in. If you want to build a deep neural network like that with so many layers, and in TensorFlow, this is like just a handful of lines of code, right? So one reason machine learning is so popular is because the code's so easy to write. The second reason machine learning is so popular is because stuff like TensorFlow, stuff like Vertex AI. I can take my code and I can upload it in here, and I can build what TensorFlow calls a training pipeline, right? The training pipeline you basically define with Python usually. And you're not like coding Python to do work. It's more like you're describing what's the step one? We'll load the data. So you write some Python code to tell, Vertex where to find the data, right? Well, what's the step two? Okay, well, let's get the model, right? Or, maybe we do some transitions on the data, or some conversions, or some, cleaning of the data or something. And maybe step three is we load the TensorFlow code. And then what we do in Google is we say, hey, Google, could you give me this much compute power? And I want to use it for up to 2 days or until the metrics for my model get to here, right? Machine learning, when you're learning, you can measure how good is this model, how quality is this model, if you will. So maybe when my quality metrics get to here, I stop training, because you're going to pay per second in Google Cloud for anything you do, right? So maybe I stop after so many, when I get to a particular quality metric, or maybe I stop when I get to some max time or something, right? So Vertex can help you with training, right? It can help you with training. It can help you test stuff like this, right? Now, really though, building your machine learning model from scratch is actually your last resort, right? When I go into a machine learning project, my first thought is, I hope I don't have to build it from scratch, right? Because there's a lot of other stuff out there we can leverage, right? For example, AutoML. AutoML is a technology in Google where Google can help write the machine learning for you, right? Not help write, Google does write the machine learning for you, right? AutoML, give me a second. This is a good couple of pages, by the way, on Google Cloud AI products in general and Vertex AI specifically. This is a couple of good links for you, right? But anyway, AutoML, take a look at like these links here. But what AutoML does is AutoML has this thing in it called the neural architecture search model. And what you do with AutoML is you upload, say, a table of data, right? AutoML will work with tables, AutoML will work with several types of data. But let's say my credit card transaction fraud example, right? Let's say I go to AutoML and I say, AutoML, do you see that table over there? That is the last 15 years worth of credit card data, right? And AutoML will say, give me a minute, and it'll go analyze the table and it'll do statistics on all the data it sees and, mins and maxes and standard deviations and all this stuff. And then it'll come back to you and it'll say, what do you want me to do? And you can say, do you see that column that's either fraud, not fraud? Yeah. Can you learn to predict, is it fraud or not fraud? And AutoML will say, how long do you want me to work on that problem? How about 24 hours? Work on it for 24 hours or until your quality metric gets to a good. Okay. And it goes off and it just tries to solve the problem, right? And this neural architecture search thing from Google, right? What it really does, what it really does is it kind of it tries to figure out, which model is going to do the best job, right? It's got all these different ways it could solve this problem. There's all kinds of standard machine learning approaches to doing a binary, choice like that, right? So if I'm trying to do some sort of, binary logistic regression or something, and I'm trying to figure out, is it this or that, right? Which approach should I take? And it kind of just figures it out on its own, right? So again, instead of you coding it, Google's got a machine learning model that codes it for you, essentially, right? And then it'll come back and it'll say, okay, I worked on your problem for 6 hours. I got to the quality metrics that are good enough. You want to try this model out? It just does it for you. Now, I forgot to mention one other choice over here. You see this choice right here, the BigQuery ML. BigQuery in Google Cloud is a data warehouse query tool. It is not a traditional relational database. It's not good at insert, update, and delete statements. It's a select tool, right? You can put petabytes of data in it and you can run SQL selects over it. Well, yeah, but there's a sub component in BigQuery that Google has built called BigQuery ML. And BigQuery ML, it's kind of like you basically use SQL syntax to train a model. You use SQL syntax to train a model. So it's kind of an interesting choice. If you really know SQL really well and you know BigQuery, and if the data, like my example of credit card transactions, if the data is in BigQuery, you can use the SQL syntax to train the model, which is kind of interesting. Is that a hand up icon? I'm sorry, I've never used this meet technology here. So, did you have
Yeah,
a question?
yeah. It's an hands up icon. Yeah. So I wanted to ask because I already have a lot of questions I want to ask already. So I wanted to ask: is it good, or is it, or would you like if we ask the questions now, or after you're done with the presentation, so that
No, yeah, ask as we go. That's fine with me.
Okay, so there's the first question I wanted to ask regarding the feature picking after you're done with the data set. Because I also never said that actually also at a point in time try to dive into data science and train machine learning models and so on. So one thing actually usually bores me up or usually bogs me down is picking the right feature to understand how to solve it, like the right features that will make you build a model that will be efficient enough to solve that particular problem. Because there was a time I was trying to go into cargo and I saw a CSV file that have over like 200 columns of
Yep.
different things. Some are text,
Yep.
some are numbers. It was highly confusing. I just left machine learning and I was okay, I'm not doing it again. This is too complex for me, right? So I wanted to
Yeah.
know is it like first of all, what methods do you use to pick features to use for a model? And also, you mentioned AutoML automatically builds model. Is it that it looks for important features in the data set, or it just does everything randomly?
Um, okay, so first off, your feature question is basically what you're really asking is how do you do what they call feature engineering, right? Feature engineering is if you have 100 columns of input data, right? Think about a credit card transaction. If I know that I did a credit card transaction on Victoria Island in Nigeria, you know, and I know if I did it at this time of day, you could figure out what's the weather like. You know, was it raining that day? When that credit card transaction was done, was it raining or not? Does that have anything to do with it being fraud or not? Right. So the reality is there's probably way more pieces of data that you know than you're going to need. Right. If I put in every piece of data that I know, it makes the idea and the math and the process of training much more complex, right? So if I'm dropping in the weather and all this stuff that maybe that's not as important to is it fraud or not? You know, it, all that stuff, it makes the math more complex. It makes it harder to deal with, right? So what feature engineering is it's basically, how can I find the columns that are of most important, right? The most important columns to this training. Maybe I figure that weather doesn't have any impact on whether it's fraud or not fraud. So maybe I leave the weather out, so that's kind of feature engineering. I guarantee you, as we go to the future, this is going to be a full-time job for people, right? There are going to be people who are experts at feature engineering, and not only experts at feature engineering, but they're going to be experts at feature engineering for particular industries. I'm a banking expert. I know banking really well. And so I'm a feature engineer for banking. Oh, you want to do credit card fraud transaction? Let me tell you, these are the most important pieces of information. So feature engineering, there's definitely an art to it and a science to it, right? So the art to it is people who have experience and they can kind of figure out why might this be important. The science to it is going to be statistical analyses. Okay. When I went to university the first time, they threw me out. That's another story. I did 4 years in the military here in the US, and then I came back to college. And when I came back to college, I studied to be an actuary. Actuaries are, you do statistics for insurance companies, stuff like that, if you're an actuary, right? So in other words, I went to college to be a statistician of sort, right? So, you know, a lot of classic statistical analyses plays a big role in this as well, right? So trying to figure out which columns are important. And then sometimes I think, mentioned the idea of combining columns. Sometimes what you'll do is you'll have multiple columns and you'll combine them. Maybe I've got these 5 columns and I can do some math and get one combined value, and I'm going to go with that. But that's an entire world unto itself. Feature engineering, like I said, right now, most of your machine learning practitioners, they're kind of doing feature engineering on their own. But the reality is you need more expertise, right? If you're doing credit card fraud transactions in the United States, you would need to know information about things like, well, what are the most fraudulent charge types, right? There's stuff like that someone like me, I'm not a credit card fraud expert. right? So I would have to work with an expert who could tell me, well, what are some of the kind of most important things? I actually talked to a guy on this one time. In the United States, the most fraudulent credit card transactions are people buying jewelry and people buying guns, right? If you buy a gun in the United States or you buy jewelry in the United States, you can buy it in one store and you can turn around and you can sell it for almost the exact same cost, right? So if you're looking for a fraud, if suddenly someone goes out who doesn't normally buy lots of guns and jewelry and they buy a bunch, that might be fraud. Okay, so again, that's the kind of knowledge that a banking expert would know. And so yeah, when you're doing feature engineering, there's no one right answer. It's more, I need to talk to someone in that industry who can maybe help me. Now, after that, maybe what you do is you get down to a bare set of features and, now maybe you start looking at other features. Once you start training a machine learning model, there's a lot of game theory. Game theory is you look at a football team and you're trying to figure out, which is the most important players kind of thing. Game theory is the math around doing that. Well, they've adapted game theory instead of, the players on your, football pitch. You're looking at features in your machine learning model, right? So there are some machine learning ways to examine features, and AutoML has some of that built in, right? When you train a model in AutoML, for example, what it does is it does a lot of trial and error. It builds a bunch of models, and then what it does is it tries to figure out, okay, let me try to solve this problem 10 different ways, and it runs them all at once. And then, wait a minute, this one is not getting better, throw it away. This one's not getting, these models are getting better, 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 better. Oh, but this is the model that gave me the best answer. So AutoML is doing a lot of, it'll use all the columns that you give it. It's not really doing feature engineering, but after the fact, AutoML can tell you which columns contributed the most, right? So AutoML does do analyses to tell you the feature importance.
Oh, that's really nice. It actually already explains everything to me. It's clearer now. I would say the due to the analysis it does, it can actually figure out the columns that actually making the model less accurate, and the ones that contributing to the accuracy of which model it's creating. Yeah,
Yeah,
that's good. It answers my question. Please, you can continue now.
excellent.
Yeah, you continue.
I will
Yeah.
also mention that
Okay.
TensorFlow has a bunch of stuff in it to help you with this as well. TensorFlow has some sub libraries to help you do statistical analyses of your data sets, right? Also, if you train a machine learning model, when you train machine learning models in Vertex, they end up in something called the model registry, right? In the model registry, it also can help you evaluate the importance of your features. That's something else that the model registry has built into it. Okay.
Nice. Thank you so much. Thank you so much. Please,
Yeah,
yeah, you can go ahead on the BigQuery ML. That's what you.
right. So the BigQuery ML is SQL syntax to train a model, right? And again, uh, BigQuery ML. BigQuery ML looks, here's a nice intro link on BigQuery ML. I'll give you a link to this links file here. I got a bunch of links in a file here. I'll give it to you in a second. But BigQuery ML, it looks like that, right? So that right there is a SQL statement that is basically saying, I want to train a new model, create or replace model. I want to train a new model named census model, right? I want it to be logistic regression. Okay, so logistic regression is a model type. Model types, when you approach machine learning, there are several main model types that you have. In other words, there's several main types of problems that you're trying to solve. A logistics regression is you're trying to categorize some data, right? So classic example of logistic regression would be my fraud, not fraud, right? That would be called binary logistic regression, where I'm trying to do logistic regression and I just want yes, no, spam, not spam, fraud, not fraud, that kind of stuff. But logistic regression in this case, I think can handle up to like 50 categories or something. So how about I want to analyze spend patterns? And I want to figure out, I want to classify my customers. Sometimes they call this t-shirt sizing. I want to classify my customers as I want to classify my customers as, are they small value customers, medium value customers, large value customers, or extra large value customers? Because maybe if you're an extra large value customer, if I know you're going to spend a lot of money at my company, maybe I change the way I advertise to you or something, right? So if I wanted to take all my users and categorize them into one of four categories, that's something I could do with logistic regression, right? Anyway, so what this is doing is this is going to train a model. This is saying, hey, BigQuery, here's some input data, right? Here's some input data. This is a classic machine learning problem based around income data in the United States from the U.S. Census Bureau, right? I know these people's age and their working class and their marital status, and I know how many hours. I know this about them, and I'm trying to predict, do they make more than $50,000 a year or less than $50,000 a year, right? That's what this problem is, right? So this is the incoming data. And this is where I'm asking BigQuery to get together with Vertex, because really it's the Vertex that does this work, right? BigQuery get together with Vertex and build this model for me, right? Okay. Now, the last way you do machine learning in Google Cloud is you don't do machine learning at all, right? What you do is you use something that has already been built, right? That is, you're calling a pre-trained model. This is something like the Vision AI, right? The Vision AI. The Vision AI is where I give it a picture and it recognizes pieces in the picture, right? If I go to the Vision AI page, it has a try it out, right? It has a try it out. Now, the quality of your image, the size of your image has to be below 4 megs, right? So last time I was in London, I went to the British Museum and I took a picture in the British Museum. So here's this picture I took in the British Museum. I guess that was back in 2018. That's been a while. But anyway, so I took this picture in the British Museum. You see, I uploaded. You see, it says, "Hey, I'm 77% sure you took this picture in the British Museum." Yes, I did. Right. So it can look at the picture and it knows that's a famous statue in the British Museum. Okay, so it's showing me that. Right. Object detection. There's a person. There's a person. There's a person. There's a backpack. Label detection. Outerwear. What kind of stuff does it see in this picture? What kind of stuff does it see in this picture? So that's an example of this pre-trained model. Another example of pre-trained would be Google Translate, right? I'm building an application, and in my application, I need to do translation. In my application, I need to do some translation. So here I've got some JavaScript code. And what I'm doing in my JavaScript code is, let's load the Google Translation library. Let me create a translator. I'm going to take the string hello world. My target language is Spanish, Espanol. Hey, translator, could you please translate hello world into Spanish? That's an asynchronous operation. I'm going to force it to wait. I want to wait for the answer, right? And I run this code and hola mundo. Yeah, so it does the translation for me. And again, that whole Google Translate, that's a machine learning model built in Vertex, right? But I'm calling it, I'm not building it, right? I'm not building it.
That's pretty clear. Using pre-trained models, I'll say I also have a lot. I have some experience using some pre-trained models. For example, using speech to text and text to speech.
Yep.
In Python. Yeah, I have more knowledge in this part, and then most of the complex parts regarding the actual building of the models um, eludes me. It's great. One thing I want to ask now is that I saw the Vision AI just showed us. It's pretty great because it's doing object in just one picture upload. It did object detection, label classification. It's really nice. First of all, I want to ask, using this kind of API or using this kind of model, pre-trained model in an application to maybe like detect diseases or detect some other things, is it wise or is it cost efficient to use a pre-trained model than to use a model you want to build from scratch, right? And also, how accurate are these models, right? Something like speech to text, video intelligence API, or text to speech. How accurate are these models to actually using a model built from scratch?
Okay, so the biggest thing to keep in mind when you're thinking pre-trained models versus building it from scratch. First off, the pre-trained models are, you know, the the uh, the shortest answer for you would be, is it doing what you want it to do? Right. Google has put a lot of work in these pre-trained models, right? They've spent a lot of money on these pre-trained models. But just like Vision AI, the Vision AI here, it's generally good, right? It's generally good. So I saw an example. You go to Vision AI and you show up at a picture of the sky, and it says, that's the sky, that's a cloud, it's blue, but you're a meteorologist and you want to know, is that a cirrus cloud or is that a cumulonimbus cloud? Vision API doesn't know, right? It has not been trained to do that, right? So it can tell you that's a cloud, but it can't tell you what type of cloud, right? So at this point, you have one of two choices, right? If you need to build a cloud detector that's going to tell you the different types of clouds, then option number one is Vision AI can also work with AutoML, right? So I told you that AutoML has an AutoML for images. Well, really, the AutoML for images, what it does is you build an image sample and you come up with, they would recommend about 100 pictures. You come up with 100 pictures of cumulonimbus clouds in different kinds of, you know, from different angles and different times of day. And then you'd have 100 pictures of your cirrus clouds. And then you'd have, so you would build an image library with 100 pictures of all the different kinds of clouds. I forget what there are, 8 or 9 types or something. So now that you've got your 900 images, you take them to AutoML and you say, hey, AutoML Vision is what they call it. AutoML Vision, because it links the two. Hey, AutoML Vision, can you learn to tell the difference between the cloud types? And it will say, it'll go off and it will learn to tell the difference. Okay, so the easiest and probably most cost-effective way for you to build an image detector to detect a particular type of image is going to be AutoML and Vision, right? Probably. Now, what about the custom train model? Well, remember, all this stuff that we're building in Google Cloud runs out of Google Cloud, right? So if I wanted to build an app, so you can take your camera on your phone and you can shine it at the sky and it will tell you that type of cloud you're looking at, right? That phone is going to have to talk to Google Cloud to get the answer, right? So remember, all this stuff lives in Google Cloud. If I build a pre-trained model, then in this story, you would probably be doing it for one of two ways, right? One reason you might build a completely pre-trained model is that's going to be a lot of times the easiest way you can get a model that you can download out of Google Cloud and use somewhere else, right? So if you wanted a model you could embed in an application, you might do a pre-trained model, right? Another thing, I'm sorry, you might do a custom trained model. Another thing about custom trained models that you want, that is a trend these days, is these models from Google. These models from Google are massive, right? Gemini, massive. Text to speech, massive. These models are really, really big, right? And they live in Google Cloud, and the fact that they're big is not a problem. But if I want to embed it in a device, the fact that they're big is a problem. Also, I don't need them to be multi-purpose. Vision AI can recognize all kinds of stuff. If all I care about is cloud detection, then I could probably custom train a model that does nothing but differentiate the 8 or 9 cloud types. And that's it, right? And I might be able to do that in a much, much smaller model. So that's, when you say pre-trained, I'm sorry, when you say, maybe one of these models from Google versus a model of your own, my first thought would be, is it okay that it lives out of Google Cloud? Is it okay that the app on the phone is going to have to send a message to Google and wait on an answer to come back? Is that okay? Right. My second question would be, okay, if the Google Cloud model is usable, does it do the job you want it to do? Because I'm a developer, but I'm lazy, right? I'm happy if it will do exactly what I want it to do in a cost effective way. Most of these models are pretty cheap. The pre trained models in Google Cloud are pretty cheap. You have to use them an awful lot before they get expensive, right? So if it does what I need it to do and it's cheap and it's already done, let's use it, right? But again, there might be some exceptions. The need to use it outside of Google Cloud might be an exception if you can't have connectivity, right? If I know I'm going to go out places where the cell signals are not good, right? One time I went up on a trip to extreme northern Canada. Okay. It was negative 40 degrees centigrade. It was so cold. But one of the things I learned is they don't have a lot of cellular up there, right? So I was going to places where I visited some towns where there was literally no cell signal, right? And when you're moving between towns, there's absolutely no cell signal, right? So if I know I'm going to go out into the bush, if you will, and I know there's not going to be cell signal, then I can't use a model that is hosted out of Google Cloud, right? So but yeah, generally the stuff out of Google is awfully good and also awful cheap. So does it do what you want it to do? Okay. And if not, maybe I think about something like this. I worked with a company one time. They did chicken processing. They were a food manufacturer, and they wanted to be able to when a package of chicken came off the assembly line, they wanted to build something that could tell which package of chicken is this. We've got 5 different types of packages of chicken that are coming off. Which one of the 5 is it? Well, the way they did it was AutoML, right? AutoML, Vision AI was like, yeah, that's food. Okay, yeah, but I want to know, is that a boneless chicken breast? Okay, well, AutoML Vision did that for them, right? They just gave it a bunch of pictures, and it did it just fine.
That's really really great. Wow, it's you mentioned a lot of deep points that actually someone needs to take to note when you are building a product. For example, the location where your product will be used. Is there cell signal in that location? Or how do you want to use your model? Maybe you want to use it offline or online connected to Google. That's
Yeah.
really, really great point. Noted that down already. Thanks so much for sharing that. Yeah, you can go
Sure.
on.
Okay. So the last kind of main thing, and again, I'm not sure how our timing is going to work out since we had kind of the time zone mistake here. But
Oh, okay. Yeah, I think I think we started around that will be I'm coming, let me confirm from my time here. We started
yeah,
about like your time would be maybe 8:50. I think we started about 8:50 your time.
okay.
Um Now it's around I think now it should be around 9:30 your time,
Yeah.
right?
I'm just wanting to
So
make sure you guys have the time. If you guys are running out of time, just let me know.
we have the time right here.
Okay.
But yeah, I want to confirm. So we have been covering the complex part of understanding how LML works in the Google Cloud Central group of tools. And so now, are you about to get into the Vertex AI Studio, or you still
Yes.
have something to cover up?
Well, what I was going to talk about, I was going to talk about the generative AI is what I was going to talk about now, which is the Vertex AI
That's
Studio. Yes.
that's great. Yeah, I think we can do this one for the next 30 minutes, and then we can ask questions and round it off.
Okay. Perfect.
Okay.
Okay. So in 2017, um, in 2017, Google published an article. Um, you might want to mute yourself again. In 2017, Google published an article, and the article is not a fun article to read. The article is titled "Attention is All You Need." Um, look at this abstract. The Dominant sequence transduction models are based on complex, recurrent, or convolutional neural networks that include an encoder and a decoder. Okay, so this is not an article that is a fun read. This is an article. This is an article that was published mostly from some Google researchers and a couple of university professors, right? And what they talked about in this article is two new things. Give me 1 second. Sorry, I forgot to prep one thing that I need. Give me 1 second. That's what I want. Give me just a moment here. Okay. So just 1 second. All right. So Google comes out with this article in 2017, right? And the article is "Attention is all you need," right? And what "Attention is all you need" introduced is it introduced two new concepts, basically. Can you guys still hear me?
Yeah, we can hear you.
Okay. And you can so I think my browser may have locked up, but we'll give it a second, see if it unlocks. Anyway, so they come out with the article "Attention is all you need." And in "Attention is all you need," they introduced two new concepts in machine learning, right? One concept in machine learning is transformers, right? Transformers. What transformers do in machine learning is they change the way text is processed, right? It used to be when you process text in machine learning, they basically would hand the entire piece of text to one computer, right? Now, that's fine if you want to try to build a machine learning model and you're giving it small sentences. But what if I want to give a machine learning model a book and I wanted to try to learn something from a book worth of text or lots of books worth of text or an entire library worth of books? The problem is before transformers, the entire book more or less had to be processed on a single machine, right? The way you make machine learning efficient is you can't do tons of work on one machine. What you do is you use a worker pattern, right? You do tons of work on lots of machines. So what transformers did is basically better parallel processing of text. That's what transformers did. Okay. The next thing that article introduced was something called self-attention. Self-attention. Before self-attention, in machine learning for text, they did this. This word goes to that word, goes to that word, goes to that word, goes to that word, goes to that word. So they looked at sentence structure like that. Okay. Have you ever done that thing on your phone where you say something like you type the word hello and your phone text message, it auto suggests the next word and you accept it, and it also auto suggests another word and you accept it, and it auto suggests another word and you accept it? You don't have to do that. Yeah, you don't have to do that too many times before the sentence makes no sense whatsoever. The reason is English doesn't work that way, right? No language works that way, right? So what self-attention did can perform a variety of tasks, including those on common. In self-attention, what it does is it takes a word in the sentence and it says, how is the word can related to tasks? How is the word perform related to tasks? A variety of, including. So in self-attention, it changed the way language processing is done. And that's much more the way languages work, right? If you have one word in a sentence, it's related to other words in a sentence. If you have one sentence in a paragraph, it's related to other sentences in a paragraph. Okay. So Google comes out with this article on large language models. I'm sorry, on transformers and self attention, right? And it changes the way machine learning for text works, right? Chat, have you ever heard of Chat GPT? The T in Chat GPT stands for transformers because Chat GPT uses the same technology Google uses, right? So this article comes out from Google and everybody's like, aha, suddenly we can do processing of text much better. Really, what you can do is you can teach a machine learning model to actually understand language, right? If I can teach a machine learning model to understand language, it really opens the door for three improvements, right? Three main use cases. One, okay, data analytics, better ability for computers to make sense of big piles of text. Right. That's the first advantage we get from this, right? Organizations store a lot of text. They have a lot of PDF files. They've got a lot of Word documents. They have a lot of video transcripts. They've got a lot of audio files that we could convert to text. So the number one type of data stored by organizations in the world today is text. Suddenly we have something where we can teach a computer to understand text. Conversational interface. You can talk to it. It changes the way we interact with our systems, right? This can be things like chatbots. This can be things like voice bots, right? But it's a conversational interface. I can talk to it like it's another person. My hobby is writing. So I did a presentation a month or so ago to a bunch of writers on using Chat GPT for writing, right? And Bard for writing. And my writers, writers a lot of times are not the most technical people. And so what I told them is you got to think of Bard or ChatGPT, or for us, Vertex AI Studio. You've got to think of it as a research assistant, right? Think of it as a research assistant. That's what you should do. Okay. Hey guys, I'm gonna have to restart my browser. I think you guys are locked up. I think you can hear me, but my browser is locked. So let me restart my browser. I'll be right back.
Okay, 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 no problem, no problem.
I can get back in with that. I can get back in with the same link, right?
Yeah. Just use the link, and then you get back in.
Okay, I'll be right back.
Okay.
We're going to force quit my browser. Chrome, the Chrome and my Mac operating system sometimes have a disagreement.
The Chrome always tries to eat more RAM than it should.
Yes, for sure. I'll be right back.
And yeah.
I'm back. Sorry about that. Give me just one moment here.
Yeah, good. We are still here. Um, yeah. I'm just eager to know more about Vertex AI Studio.
Yes.
Okay, so yeah, you can share your screen and continue sharing your
Alrighty.
knowledge.
Yeah. Yeah. I don't know. The latest um, Mac did that new big OS update, what, back in November or something. And um, ever since then, my Chrome and my Mac have been going back and forth. Give me just a second. What is my code? So I'm going to use Safari here. So maybe Safari won't freak out on me. Okay. So give me just one moment. I'm using a demo environment I have for. Okay. All right.
Oh,
So
okay. Okay. Is it like you want like share like a kind of a demo workshop?
yeah. I'll do a little demo on the Vertex AI Studio here. Yes.
Okay. Thanks.
Yeah. Okay. So give me one moment here. Okay. So we were talking about large language models and the way large language models worked, right? Okay. So um, Google did not jump right on this. They kind of worked on this slowly. And so they were kind of behind the curve a little bit when ChatGPT came out, right? But Google has been pushing into this space for about the last year or so, right? And since they wrote the white paper, and inside of Vertex AI, the main part where they've got our generative AI capabilities. I was telling you the three main ways that this helps. The data analytics way, the conversational way, and then of course the last way is the generative technologies, right? The generative abilities. Okay. Because I can now go from like what's in the picture to create a picture. Or, is this post positive or negative? Yeah. Right. So your basic generative AI large language model, mostly capabilities you can find are in Vertex AI Studio, right? Vertex AI Studio is then subdivided into several actual models, right? There's the language model section. This is Palm. This is Bison. This is a large language model only. There is a vision model section, right? And the vision model section is not quite finished yet, right? So you see it's not quite available yet. But the vision model Google calls Imagine. It's spelled image gen, but it's pronounced Imagine by Google. So the Imagine is a model that can do image recognition. What's in this picture, but it can also do image creation, right? Um, there's a speech to text to speech model, and they even have one now that can build a custom voice, right? So they've got one that's coming out that you'll be able to create a custom voice for your text to speech, which is going to be kind of interesting, right? The multimodal is their new Gemini product, right? Gemini is a multimodal model. And what multimodal means is it's basically multiple models built in. There's a language model built into it, but there's also a vision model built into it. There's a math model built into it. There's a logical reasoning model built into it. So, in other words, they've got a bunch of, when they say multimodal, it's really like multi-model, right? There's multiple models constructed inside of it. Now, I can go to the multimodal page, or I could go to the language page, right? And what I can do is I can ask it to give me a prompt that I can start interacting with, right? So when you have large language models, you know, when you have a large language model or when you have these generative models, right? There's kind of three main ways you can customize a generative model. The first way is you can do what's called prompt tuning, right? Prompt tuning. Prompt tuning is where you set a context, you provide a few examples, and you see if that's enough to get the model to work the way you want it to work, right? You context, right? You work for a online news service in New Orleans. Okay. Your main job is to create restaurant reviews. Right. So your main job is to write restaurant reviews, right? You tend to tell lots of jokes and sprinkle Cajun phrases into your reviews. Okay, that's a prompt. Okay, I've set a context, right? I've set a context. I'm not providing any examples in this case, but you set a context. You work for an online service. When you work with when you work with generative models, talk to them like they're a person, right? That's the easiest way to make your brain work around this. You work for an online news service in New Orleans. Your main job is to write restaurant reviews. You tend to tell lots of jokes and sprinkle Cajun phrases into your reviews, right? Okay. Now, what I would do with this model, right? Now, what I would do with this model, now that I have it prompt tuned, is I can ask it to write restaurant reviews, right? So now what I could do is, input. By the way, you don't have to count where I'm typing input. You don't have to do it this way. You don't have to type context. You don't have to type input, but it makes my brain. It makes it work with my brain. Input. Write a new review for the steak restaurant. The Butcher Block. You had a New York strip, and it was fantastic. Okay, so this is prompt tuning. This is where you've set a context, and I'm now using my context. Now, right now, I'm doing it with text. Let me show you how to do it in code in a second, right? Okay, so let me see if that works the way I want it to work, right? I've got some options over here. I'm not going to mess with any of those for now. Let me hit submit. Let's see what it gives me. The response was blocked because it may contain descriptions of violence, sexual themes, or other derogatory content. Okay. Wow. Yeah. Let me check my safety settings here. Okay. Let me lighten up my safety settings for a second. So apparently it included a dirty joke or something in the response and it cut it out. Okay. Y'all, let me tell you, the Butcher's Block is the bee's knees when it comes to steakhouses. I recently had the pleasure of sticking my teeth into their New York strip, and let me tell you, it was a religious experience, right? The steak was cooked to perfection with beautiful crust on the outside. And yeah, okay. So anyway, it wrote a restaurant review. Now, let's say I wanted to use this multiple times to write restaurant reviews. right? You tend to be funny. I'm going to change this a little bit and sprinkle Cajun phrases. I didn't see any Cajun phrases in there, but hey, Cajun, if you don't know, in New Orleans, the Cajuns they come from French heritage, right? The French lived in New Orleans first. And so there's still a lot of people kind of out in the country around New Orleans, and they have a French accent, right? And they use kind of these bastardized French expressions sometimes in their English, right? That's what Cajun is, if you're not familiar, right?
Okay, okay.
Okay. Now, let's say this is doing what I want it to do, right? Yeah. Okay. So now I'm seeing it sprinkle some, yeah. Now I'm seeing it sprinkle some phrases that are more French or Cajun into the result. Okay, so what I could do is, let me take out the input here. Let me take out the input. Up over here, do you see where it says get code? Let me hit get code. And what do we want? Do we want Python or Node or Java? I'm going to do Python, right? And you see what it'll do is it will now show you if you wanted to use this in your code. If you wanted to build a little web page and you could just go to it and get a restaurant review.
I'm sorry. Please, can you just take a little bit step back? I couldn't see the place where you said get code.
Yeah. Do you see it's literally a button here in the upper right-hand corner of the page?
Oh, okay. Clear.
Yeah. So I went to this. So I have done prompt tuning. I've kind of told it what I want. I've got the input, but I'm leaving it blank. I go to the little button that says get code. It pops up the window to show me code. And again, I could see it in JavaScript, or I could see it in Java, or I could see it in Python. I'm just going to go with the Python, right? And it'll tell you, what do you need to do to make this work, right? Well, first you install the Google AI platform, okay? Then what you do, okay, hang on, sorry, my zooming here has messed me up. Okay, then what you would do is you import some of the generative models. You load the Gemini Pro model. Okay, now I'm not sure why it's using Pro Vision. It should just be loading Gemini Pro, but okay. Then do you see where it sets the context and do you see the inputs in there waiting for something? Okay. So what you would do, and that's just inside this generate function, right? Let me do it this way. Okay, that's not working. That's fine. Okay, so, I see. One moment. I asked it to open it in a notebook for me. So do you see this is a Jupyter Lab notebook? Okay, so I hit the button that said open in notebook, right? Open notebook, and it just opened it in a notebook for me. Okay. Anyway, so do you see? Here's my Python. I got a generate function, and now can you imagine? All you really need to do is you would put a variable right there. You would put a variable right there, and that would be whatever the input is. So can't you imagine now? You have a web page, and it says, type a description of the restaurant you want me to write a review for, right? And you type in there and you say, I went to the butcher block, I had the New York strip, it was really good. And you drop that value right there. You call this function, it calls Gemini in Google Cloud, and it gives you the results back, right? So that's what the generate code will do, which is kind of cool, right? So that's the way prompt tuning works. You kind of come up with what you want it to do just by kind of describing what you want. You kind of describe what you want. Then you kind of get it working. You maybe test it a couple times, make sure it's working the way you want. And then you say get code, and that's what you integrate into your application, right? That will work with Gemini, which is a multimodal model, right? That will also work with your language models, which are like Palm, which is a general text generator. And you also notice in Palm, they have a chat version. The chat version for Gemini is not out yet. What if you wanted to do the same kind of deal, but you wanted to build like a chat engine, right? Okay, that's prompt tuning. The next thing you can do in Google is you can do fine tuning. Fine tuning will work with some of these models. And in fine tuning, that's the tuna model right there. What you can do is you can say, here's 100 common questions that I get asked, and here's the way I want you to answer them, more or less. And you kind of teach it how you want it to sound, and you teach it sort of the data it should know by example, right? But you can only give it maybe hundreds or thousands of examples, right? The last thing you can do, and this will, then I'll open the floor for questions. The last thing you can do with all of these is you can do what's called grounding, right? Grounding. Do you see over here, there's a setting, maybe. Over here, there's a setting. Do you see enable grounding? Enable grounding. What grounding does in Vertex is there's a part of Vertex in grounding. They don't have it in the Vertex AI section. Where they have it is they have it in another section called search and conversation. And what you can do in search and conversation is you can provide a data set, right? You can provide a data set. The data set will be where is the answer, right? Where is the answer? A data store, sorry, right? So in grounding, what you do is you provide a data store. It's a website, or it's a database in BigQuery, or it's a file storage, cloud storage location with a bunch of files in it, right? So in grounding, you provide the data.
Yeah. I think thanks for mentioning this. I think I've seen this once when I was working on a project where I was using Elastic Search. So there was an example whereby they provided the script for Game of Thrones, like all the
Ah,
seasons, and then like we like provided that data as a kind of this kind of grounding data so that Elasticsearch API can use that particular data and search for answers in that data. So is that how this thing looks like? Like for example, I would want to build a solution whereby, let's say, I want to build a smart FAQ section on my website, and then I
yes.
provide that link to my website, and then it automatically understands how to answer questions regarding the service we provide.
That's exactly right. Right.
Wow, that's nice.
So what I can do here is, I could say, let's go ahead and build a um, data set, and I want the data to be found on the Zenith Bank website, right? So I can point it, if the answer's on the Zenith Bank website, I want you to use that, right? So you can like give it a URL. Yeah, that's where I want you to find the data. This is the, the Zenith Bank site. You tell it where to find the data, and what it does is it just looks at the data on the website, right? And so you tell it where to find all the data, and then what you can do is you can say, okay, I want you to answer questions, large language model, but I only want you to give answers that come out of this data set, right? So this is what's nice about the fact that the large language model can understand text, right? So now you basically are feeding it a bunch of text, and you're saying people can ask anything they want, but only answer things where the answer can be found over here. And it doesn't just see the text, it understands what the text means, right? So it can read the text, it can read the website, it can read the FAQs, and it can say, okay, this is where, I'm going to get my data from, right? And once you have that in there, now your large language model can use that. Also, another generative AI feature that Google has is you can get it to build search apps or chat apps or recommendation services using those data sets as well, right? So if I wanted to build a search app for the Zenith website, you know, if I wanted to build a search app for the Zenith website, I can build a search app for the Zenith website. And again, it's driven using my large language models, right? I've never tried the Zenith website before, but let's see if this works. What account types do you have? Here, okay. Okay. Yeah, I've never tried it on this website. I'll have to play around with it a little bit more. Okay. But anyway, yes, you can build it, you can ground it in a set of data, right? So you can prompt tune, you can fine tune, you can ground. And in all of them, Google will help you generate your code, right? So Google will help you generate. If I want to use my currently not working search engine, how would I embed it on my website? Google will show you that, right? How could I call the API directly, right? Google will show you that, right? But what's some of the most interesting stuff, though, is what we were talking about before, right? When we were over in Vertex AI and we were looking at Vertex AI Studio, because here you can experiment with the model before you tell it to generate the code for you, which is really pretty cool.
Wow,
All right.
that's amazing. This has a lot of features, and I'm seeing a lot of things here. So we've learned a lot today. Like you've shared a lot. I didn't even know how you did it. You went from high level, from general machine learning understanding, and now we are at Vertex AI Studio. It's really been great. Wow, it's really been a great journey. So yeah, what I want to say now is that I have some questions I want to ask, right?
Okay.
I don't know if you I actually have some questions I want to ask regarding your tech career as a as you went all the way from learning simple languages to being an instructor at ROI. But first of all, I want you to for example, to suggest some things. So I have a question. So for example, let's say I want to build a solution that is trying to solve, let's say, um, climate change, right? Solve a problem regarding, let's say, carbon emissions, right? So, and I'm looking, okay, so my solution is that I want to be able to suggest, let's say, locations around the world in your area, actually not around the world, in your area where you can plant trees and then you use those trees, like let's say that those trees can balance out the emissions that are coming out in your area. So if I want to get started on that, and I want to use AI to do that kind of decision making, what processes would I take before I can get there?
Well, I think in machine learning models, you have to start with, what is the data you're trying to get to, and what is the data that you have, right? Machine learning models in traditional programming, you start with the data, you write the code to make the decisions, and you are kind of creating the algorithm, right? In machine learning, you kind of have, well, this is the data I'm starting with, this is where I'm trying to get to, can the machine learning model give me a path between the two? In other words, can the machine learning model kind of create the math for me, or the algorithm for me, if you will, right? So I think your climate change model would probably be a tough example unless we have really good data on, or do we have examples where this has worked before? Do we have examples where, these are areas where, no trees were planted, and this is what we're seeing with the data. These are areas where trees were planted in these different ways. Can we figure out which of these ways is best? So machine learning models are kind of good at sort of analyzing that. Now, there is a sub-study of machine learning, which is sometimes called unsupervised machine learning. Unsupervised machine learning is where you may be looking for things like patterns, right? You may be looking for things like patterns. And so, what you're trying to do is, you're trying to look in patterns in all these noise. So you might be able to use some sort of unsupervised algorithm to try to find those best use cases, right? But yeah, I don't know. That's a really tough one. I think we would have to talk about that one a lot more. But I
Okay.
think, most machine learning models, I know where I want to go. I know where I'm starting. I have lots of examples, but I'm not really sure how to consistently get from here to there, right? Like you and I can look at that number 9 in that box. We can tell that that's a number 9, but how do we teach a computer to be able to do that same human-like thing, right? Yeah.
Wow, that's really, really great. Yeah. So I think finding data would be one of the complex parts of creating machine learning models. Then.
A lot of times you could argue that is the biggest problem, right? The biggest problem in a lot of machine learning is finding the data, but the data also has to be good, right? So, for example, when there was, I forget, it was either in the U.S. or Canada when they very first built a machine learning algorithm to do facial recognition, right? The guys that built the college students that built the machine learning model, they were all light skinned, right? So when they built the machine learning model to do facial recognitions, they took pictures of each other, they took pictures of their friends, their parents, and their college professor. Well, they were all very light skinned. And so they built the very first facial recognition model, and it did a pretty good job with facial recognition if you had light skin. But if you had dark skin, it didn't work very well. Well, yeah, because the machine learning model never saw a lot of dark skinned people when it was training, right? So, that's called bias, right? So when you build your machine learning model, it's not just can I get enough data, but also you have this tremendous problem of how do I try to get data that's avoiding things like bias, right? Now that is an obvious form of bias. They should have known better, but they weren't thinking in terms of bias when they did that. But still, there's lots of kinds of bias that may be totally unintentional in the way you build your data. So there's a lot of, sometimes they call it responsible AI. There's a lot of ethics, shall we say, around machine learning. But trying to get lots of data, but it may not be bias problems. It may just be, is the data clean? Does the data have errors in it? Does the data have bugs in it? Does the data have answers that are wrong? So a lot of times one of the biggest problems around machine learning is trying to get that data that's actually going to be good.
Oh, that's really, really insightful. Thanks so much for that. Yeah, I would say I think that's everything I have. Right, I might be tempted to actually make you come again on another call, but yeah, yeah, that's suggestion. But yeah, let me ask the attendees right now. Mr. Miracle, Mr. Nelson, does anyone have any question at all? You can type it in the chat box if you have any question. To just clear your minds out. Okay, so I think no one have any questions yet. So yeah, my question is that if or let me see how would I place this? If as you were building, as you were going around learning and increasing knowledge, how do you pick the path, or how did you pick the path you want to take? Like, okay, I want to become a full stack engineer. I want to much more dive into maybe AI, or I just want to expand my knowledge in this part. Like, how do you do that, right? And again, how do you gather, or how I would say, how do you plan yourself to ensure that you accomplish, or how do you break down your goals to ensure that you accomplish that goal? That's the main goal.
Well, I don't know. I think you have to be open to opportunity. My first programming job, I taught myself to code. I did not go to school for it, right? So, I taught myself to code. The first job I got in programming, I was hired as a tech support rep. So I got hired as a rep, and I was working technical support and on the phone, phone-based technical support.
Wow.
And they were a job at the company came up for being software development, and I just told them, hey, you know, I've taught myself to code. I would be interested in trying out for this job. Also, I have to say that, in my career from that day to now, even though I'm still in IT, even though I'm still working with computers, even though, you know, I probably do more Google Cloud these days than writing code, but still, I still write a lot of code and everything else. I think you have to open yourself up to opportunity, right? You have to be the person that when there's some weird technology that comes out and they're like, hey, anyone want to try to figure out how to do such and such? If you're the person that says, I'll give it a shot, that if you're willing to be flexible and you're willing to go through the pain of learning new stuff, if you don't like learning. Now, I don't like learning about literature, right? I like learning about computers. I like learning about Google Cloud. I like learning about machine learning. So it's okay to be restrictive, but if you don't like learning, you're not going to succeed in a IT job, because the way the IT world works today is so much different. Realize when I started in IT, there was no internet. So the world changes. Right now, we are at another change. The internet totally revolutionized how businesses work. Generative AI is going to be another big revolution. There's going to be massive changes in IT thanks to generative AI. So you can move into the IT world, but I used to write nothing but Perl program. Then I wrote nothing but JavaScript and Java. Then I wrote nothing but Java and C Sharp. These days I write JavaScript, Python, Java. I haven't done C Sharp in a while. So, and also these days I'm doing more cloud oriented stuff and helping organizations. Most of my job is Google sends me tomorrow morning. I leave for Atlanta, Georgia. I'm going to the Google office in Atlanta, Georgia, and I'm going to be teaching up there for the week on how do you use Kubernetes in Google Cloud. That's something I had to learn, because, and that's not a programming job, but it's still in IT. I still enjoy it. So you got to figure out what is it that you enjoy, and yeah, what is it that you enjoy but you can make money at, right? When I went to school to learn statistics, you know, I could either be an actuary or I could teach high school math. I didn't want to teach math to kids, right? So I wanted to be an actuary. Okay, yeah, but then I discovered I actually like computers better than that. So I went to computers, But again, that's another job where I could actually make money, in computers. So, you do have to think about things you enjoy, but things that you can use to support your family. But I've had to move. I've moved. I'm still in the United States, but I haven't been. I haven't lived in the town I grew up. For 35 years or something. I've moved. I've lived in San Diego and I've lived in Atlanta. I've lived in several major. So I took a couple of jobs where I had to move to a different city. And the U.S. is pretty spread out. So from where I am to when I lived in California, that's like a 3-day drive from where I am now. So it's you might have to move, but if you're the person that says I'm willing to give this a shot, I'll learn, that will serve you well. It will allow you to find those opportunities, and yeah, you have to look for them. I really love my job that I do right now, teaching classes for Google, but there might be a better job out there sometime. What I'm not writing as much code anymore. I really liked the writing code, but I'm not writing as much code anymore because the demand, there was more demand around me doing Google Cloud work than me writing code work. So I'm still writing a fair amount of code, but not as much as I used to. Now, a lot of times I'm helping them set up the environment where their code is going to run, right? Or I'm helping them show them how to get their code working in Google Cloud. So, IT is a great career. There's a lot of stuff, but in IT, machine learning is a big subsection that's very hot right now. The ability to use generative AI is really hot right now. But again, that's probably going to supplement your job rather than be your main job. For example, IntelliJ, the JavaScript editor, and PyCharm, the IntelliJ people, they just came out with a AI feature to help use generative AI to help you write more code. GitHub, which is owned by Microsoft, has Copilot now, and a Copilot can help you write code. So it's not writing code for you, but it helps you write code. So maybe you start learning, if you're writing code, how can I get generative AI to help me write code? So I think be willing to be that person that takes the extra time to learn that extra thing, right? If your boss likes you, if your boss likes you because you're one of these people that can kind of get along with people, right? That can help you. I'm very shy by nature. I had to learn. I was not a let's get up in front of people and speak person, right? That's something I had to learn, and it was painful because, that was not me. I'd rather have a book, be in the corner reading my book. I'm an extroverted introvert. I don't mind teaching anymore, but when I'm done teaching, I don't want to go hang out yeah, I want to go back and like relax all by myself because I need my alone time now, So, but can you make yourself, interact with people? Can you make yourself get along with people even if they're unpleasant? Can you say yes, I'm willing to go learn how to do that thing. I will give that a try. That's the stuff I think that served me more than anything else. Your core job will change, from where I was started in tech supports to where I'm doing stuff I'm doing now, it's light years apart, but still, it's still in IT. I still spend lots of time learning stuff on my own, but most of my stuff learning now is I'll get a call from my boss or from someone at Google and they'll say, we need some, how did I get into generative AI? Well, in March of last year, Google called me and said, we need someone who can write classes on generative AI. And I was like, I don't know much about generative AI, but I've written a lot of classes for Google before. So I said, yes, I'm willing to write some classes on generative AI, but you need to put me in touch with the people who can tell me what I need to know. And so I had to learn in this like very short period of time a bunch of stuff about generative AI so I could write a class on generative AI. I mean, if you're willing to do that kind of stuff, put yourself out there like that, then yeah, that's the stuff. Opportunity will come to you sometimes in weird ways. Yeah.
Wow, wow, that's really, really great. Thanks for sharing this to really help a lot. I've always had this what do I call it, this trouble making decisions that, oh, and should I learn more or should I go out of my current stack and maybe learn about maybe machine learning or blockchain? Won't that be like I'm taking too much on my hands? Like I've always been deciding that, but yeah, yeah, I think now it's as you've said, it's not much like they would be my main job, but they will supplement my current job. I could pivot into maybe one thing I learned then or learned now, and then it will be yeah, it's actually great. It's nice. Yeah, one last thing I want to ask is that I'm very, very surprised that you said you actually worked in Nigeria before. So I wanted
Oh
to ask, how did that happen? Like, is it like
yeah.
you were contracted from US over to Nigeria, or you found an
um,
opportunity and then chased it?
I've been there a few times. It was mostly training, right? So for the majority of my last, I don't know how long, I've been a mix of consulting and training, right? And I've worked for a few training companies, and you know, I never said no if they wanted to send me somewhere that was maybe different. I was always again the guy that I've been to Haiti, I've been to Nigeria. I've been to a bunch of different countries. And it's basically my boss said, we have this bank in Nigeria that they want to do some Java training. They want a month of Java, right? Is one of the last time I was there, that's what they wanted. They wanted someone to teach them Java, everything about Java basically for a month. And I said, sure, I'd do it. So that was like the last time I went to Nigeria was it was through a US based training company, but a lot of the US based training companies, they do training all around the world, right? So that was it. That's the way I
Yeah,
ended up in Nigeria.
oh, that's really, really great. Yeah, that's amazing. Well, you've had a lot of experience doing a lot of stuff. Yeah. So, apart from the AI, machine learning, and so on, what other aspects of the tech industry have you been fascinated by? Like, you would love to maybe learn about this, or you have learned about it before and then you came into machine learning.
Well, again, I think there's a lot of technologies in cloud. You know, um, like right now I'm writing a book for the publisher O'Reilly on passing the Google Cloud Architect certification. So I think besides software development, I think the cloud in general is kind of an interesting area, and companies are very hungry right now for experts to help them work into the cloud. The way I ended up in Google Cloud is I was writing code and I kept getting hired by companies to come help them with code, but they wanted to run the code in the cloud, right? And I didn't know anything about the cloud. And suddenly I started running into problems. The code is working fine in the dev environment, but when we move it into the cloud, it's not working. There's something wrong with the cloud.
Classic
And so
problem.
yeah, and so the way I got into cloud was that, I had no that it was like nowhere on my current schedule that I should learn about the cloud. But I started showing up and I would, yeah, okay, we want to run this in the cloud. And I'm like, well, let me start learning about the cloud. So I played with AWS, I played with Azure, I played with Google's cloud. I'm like, these are the big three clouds, and I did a little bit in all three, and I kind of like Google Cloud's best. So then I started saying to my clients, well, hey, you're writing this application. Have you thought of running it in Google Cloud? And oh, we don't really know how to do that. Well, let me show you how to do that. Um, uh, but so that's like another area. So that kind of sucked me more. So the cloud, you could say it's more an infrastructure technology than it is a developer technology. Yeah, but the fact that I'm a developer helps me a lot because what do people want to do? Well, they want to make practical use of the cloud. Well, what does that mean? Well, a lot of times that means I have an application and I want the application to work in the cloud. How can I get this application working in the cloud? Right. And so data processing, data analytics, again, data analytics is a huge field. And there's a lot of people, companies are doubling the amount of data they gather every like 3 or 4 years now. So your companies are collecting more data than ever, but how do they analyze that? So I didn't know much about data analytics, but hey, I knew some SQL, I knew some SQL. I could learn, like down in Vertex. I didn't show you. Oh, I'm not sharing my screen anymore. um, but I don't think I showed you down in Vertex. Down in Vertex, they have like what they call workbench. And what this is Jupyter Lab notebooks. Jupyter Lab notebooks is kind of a environment where you can like write documentation and code. That's
Yeah.
big in data analytics. You know, that's big in data analytics. And so, like I said, if you're open to maybe doing jobs a little bit outside your niche, that's something that I think is of interest. I'll also say if you go to work for a company and they want you to do the same thing every day, all day long, and you do that for years, and it looks like it's never going to change, it might be time to look for a different company, right? So there 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 are companies that give more opportunities than other companies, right? These days, though, it's easier than ever for people in IT to find, another job at a different company that might be giving you other opportunities. Yeah. But you never
Hmm.
know. I just over last summer, I did a big training for a bank in the UK for new hires. These were new students just out of university. There were several students who were from Nigeria. They had graduated from a university in Nigeria, but they had applied for this job at a big UK bank, and they were hired by this UK bank. And they had just moved from Nigeria. I was working with the group. There was maybe 70 people, and there was half of it was one instructor I work with and half of them were with me, and they were all brand new hires at this big bank. So like I said, when you're looking for things like a job, there's lots of jobs. There's lots of opportunities that you may find in Nigeria. There's lots of opportunities that you may find online where you can live in Nigeria, but you can do this job online. But there may be jobs where they want you to move somewhere like the UK or Canada or something, and you might be open to those kinds of jobs too. But that's harder because leaving your family and going somewhere else is a tough decision. But still, anyway.
Yeah, yeah. Thanks more about that. Yeah, I've also heard about a lot of students in this country after they're done with their universities. They get like offers going to like Goldman Sachs and other kind of banks outside there.
Yeah.
It's nice. It's nice. Yeah. So I actually forgot one last question. I wanted. Oh yeah, I remember it now. So we've talked about how you expand your space by trying to learn new things, right? So I have this problem whereby I find it hard to decide that I am good at this thing, right? So if I want to learn cloud now because it's my schedule to learn about cloud completely, I'm heading into cloud AWS, right? I'm like, oh, I need to get so and so certificate. I need to learn about all of these topics. Like if I'm not done with this, I can't consider myself a cloud engineer or an expert in this field. Like I'll feel like I'm missing something, or I have to learn Golang. I have to build some projects with Golang, and these things are very much, and it end up consuming my time, and I end up not doing most of the things that I have in the list because they are just too much. Much. So, when you're learning new stuff, how do you consider yourself? Like, okay, I think at this level, I am good. I'm good with what I currently know. I might learn more, but yeah, at this level, I think I'm great. Like, what's how do you pick those things you need to learn?
That's tough. I don't know. And to me, a lot of times it's been back to those opportunities that have come up. I was not as strong at Google Cloud as I could have been until I got an offer to do some training on Google Cloud, right? And so, my Google Cloud was kind of weak, but someone gave me an offer to do some work in Google Cloud, and that's when I really spent a lot of time learning about details of Google Cloud. That's when I got my certification on Google Cloud. Now I'm good enough to start that. But now I'm working in Google Cloud, and they want me to do some work on generative AI. So I think sometimes your decisions are driven by by the needs. A lot of times, I think it was who's the guy that founded Oracle? Is it Larry Ellison? I forget, but I think it was the guy who founded Oracle who said, if you get an opportunity, say yes, and you can figure out how to do it later. You know, and I think I in my life have done that several times where I've gotten an opportunity. I said yes. I was thinking it sounded like something I could do. I said yes, but when I very first started, it was very painful because I had so much I had to learn, until I could really get to the point where okay, now this is easy. So I think sometimes you have to be willing to take that jump and say, yes, I'll try that, even if you're going to have to learn a lot in certain areas. And then, figure out what do you need to learn, figure out, what is good enough so I can do this job. I think you have to do some of that as well.
Yeah, so I think our time is up. This is 5:30. Usually have time in this session. And thank you so much. Thank you so much. I was actually very surprised that you would be coming and giving this talk. I just saw your chat that day in the AI section in the Discord channel. I just tried to just message you that, oh, let me just see if you would just come and make a call,
Hey, sure, why not? Yeah,
message to us. Thank you so much. Thank you so much for coming on this call with us. I really
my pleasure.
appreciate giving your time. That's really really nice.
My pleasure.
Also, yeah, I don't know. Do you have a Twitter handle? Because all I could get was your LinkedIn handle. I don't know. Are you on Twitter?
I'm not on Twitter. No, I'm just
Okay,
mostly on LinkedIn.
no problem. I think I'll be chatting with you on LinkedIn and on Discord. Then, it's like you're actually very very active on Discord. I see. I think you're very very active. You come on
Yeah,
Discord
I
like
try to get
once.
in there when I have a little bit of time. Yeah, when I have a little bit of time, I try to jump in there and put a few comments on cloud or on some of the generative AI. Yeah, so I'm in there.
Nice, nice, nice. Thanks. Thanks so much. Um, yeah, I think that's all for the day. So yeah, that's we're running it up now, and I'll be posting this on our YouTube channel. I'll be sending a link to you. Maybe you want to share to others. Um, maybe somewhere. Yeah. So that's all. Thank you so much, Patrick, for coming on this call with us.
Yeah, no problem.